An eternal threat that any life exposes its own existence will be swiftly wiped out. This is the picture of cosmic civilization. It's the explanation for the Fermi paradox.
The Interplanetary podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
Oh yeah, baby Louise.
I'm so glad you pronounced that. What a beautiful name. I mean, written down. I mean, and pronounced. Although we don't know if you pronounced it right.
I've not heard of Louise before.
Now, I don't want to be ignorant, Matt. Are they from... I don't want to be ignorant. Are they from China?
They are from China. The winner of the 2015 Sci-Fi Fiction Award, the Hugo Award.
The Dark Forest.
The Dark Forest is the second part of a trilogy. The first part being the three-body problem.
Oh, God. That's scary.
Yeah, I think there's a little bit in there. Influenced by Arthur C. Clarke and George Orwell, brings in maybe some of the politics of China and America, but sets it on a more interstellar stage.
Well, I like the sound of it. And tell you what, if you're going to be influenced by anyone, that's not a bad duo, is it?
It's not a bad call.
You know what I mean?
I've just started the three-body problem, and thanks to the Discord and the book club that we have in there, I look forward to reading this award-winning fiction.
Wonderful stuff. Now, Matt, talking of being influenced, can I ask you a question? Mm-hmm. Are you in any way influenced by Justin Roberts or Justin Young?
I don't think I could be more influenced by them. I mean, they're certainly not a three-body problem.
Hell no.
They're a two-body piece of genius. Justin Roberts, Justin Young, serving at ace level on the podcast Patreon.
Sweet vermouth. Ace level. How'd you get there?
Go to www.patreon.com/interplanetary to find out. They are total legends, and their support at ace level has allowed us to open up our podcast on YouTube. So from now on, each episode is now on YouTube, which actually is harder than it sounds, because obviously it would take forever to do it all the time. So, but no, I've managed to automate it. It cost a little bit of money, but the Patreons are paying for that. And so, yes, if you find YouTube a convenient way to listen to the podcast, you now can.
God. Massive shout out to our patrons, and Justin. What a double legend you are. I see you as... Matt, what's the mythical creature that's half horse and half man?
It's the centaur.
It's the centaur. So, Roberts or Young, which half do you want to be? Let us know. I see you as one of those galloping through the galaxy, fixing things like you fix for us.
I'm sure there's a constellation like that somewhere.
If you would also like to become a mythical creature in the universe, please head to our website, www.interplanetary.org.uk for details. Matt, what's up next?
What's up next? Well, gosh, we got a lot to get through, Jamie. We're obviously dilly-dallying around at the edges here. But
Christ, there's been some dallying.
Yes, 19th of June. 1933 was the birth of Viktor Ivanovich Betseov.
Is it any wonder that his initials are VIP?
Ah, yes. Well, he was a VIP aboard Salyut 1, where he operated the Orion 1 Space Observatory, becoming the first thing in the universe to operate a telescope outside of the Earth's atmosphere.
God damn.
So that's pretty cool. Imagine how cool looking through a telescope that's not all hazy due to the Earth's atmosphere. That must have been mind-blowing for him. Yes, yeah. Soyuz 11, that mission was, that went up to Salyut 1. And unfortunately, it's not the only first. He may be the first person to die in space as well.
Oh,
because,
God.
Unfortunately, the Soyuz 11 capsule had something go wrong. Some faulty valve meant that it depressurized too soon, and all the cosmonauts on board perished. He's not the first person to. He's not the first space fatality. That goes to cosmonaut Vladimir Komarov. in Soyuz 1. So
well,
Soyuz...
it's probably one of our animals before that, wasn't it?
Yeah, Soyuz certainly has a lot of space history associated with it.
God damn.
So do you know what's happening on the 21st of June, Jamie?
I know what's happening because I'm rather obsessed with solar eclipses, Matt. Only visible near the equator, South Sudan, Ethiopia, Yemen, Oman, Pakistan, India, Nepal, China, Taiwan, and Guam.
That's quite rare. Annular solar eclipse, so it's not the full one, so you won't get the diamond ring, but you do get the kind of, well, the moon blocking out most of it.
If you could travel to any of those places to watch, where would you go?
I think
I'd go to Ethiopia, I think. I'd like to visit there.
I think Korea gets it as well, so I would love to go to South Korea.
That's when I landed in a plane. I told you my story about that, didn't I? When I accidentally... Well, I was coming back from Vietnam and I brought back some rice... I think it was rice wine. Was it rice wine? Inside a bottle with a cobra, and inside the cobra's mouth was a scorpion. I bought it in this village called Snake Village. I don't really know why I did, because it's quite cruel looking back. But I bought it as a funny gift for my friend. And then on the plane on the way into South Korea to refuel, I read the landing card and it said, anyone caught with the following coming into the country will either get 5 years in a Korean jail or a £50,000 fine. And out of the 5 objects was endangered animals, and they listed them, and cobra was one of them.
Uh-oh.
So you could say that my 7-hour stop-off inside Seoul Airport was a very nerve-wracking one. But you'll be pleased to know, Matt, that nobody caught me and I sailed on through.
Well, maybe they'll listen to this podcast and catch up with you.
Oh, God. Let's hope not. Let's hope not.
And as you think about this, you'll have a really long day. But, of course, 21st of June is the longest day of the year.
It really is.
Yes, there we go. The sun is having its longest stopover this week. Great news for UK space, Jamie, this week.
Yes.
It's all building up quite nicely. So the UK ambassador, Dame Karen Pierce, and the US Assistant Secretary of State for International Security and Non-Proliferation, Christopher Ford, have signed a US-UK technology safeguards agreement. So basically, they're always a bit worried about technology drifting from one place to the other, and one side nicking each other's missile control software and stuff like that. So they've signed a little agreement which opens up the doors for US companies to come over to the UK and participate in space technology and space launching from the United Kingdom.
Wow, there we go.
Which actually, I suppose, really opens up the door for someone like Lockheed Martin, who tweeted that they sort of really approved here. And they have a rocket that's similar to the Electron, if not the Electron. After all, Lockheed Martin have a little stake in the Electron. And so the Electron could be the first rocket to take off from the UK as a result of this particular bit of... as a result of this agreement. So that's quite exciting. Of course, there's lots of other contenders. There's Orbex, our personal favourite, because we got a nice invite up to the Orbex factory. It's got Skyroarer, who hopefully will have an interview lined up very shortly. Virgin Orbit, but they're not going to be going vertical. They're going to be going horizontal from Cornwall. So yes, lots of
it's a good time,
exciting
isn't it?
things.
It's a good time.
A little bit of caution, though, of course, Jamie. There's still a bit of a long way to go. There's public hearings.
Very long way to go.
Public hearings for the Sutherland Planning Permission. Yeah. But hopefully that's next week, so we'll know a little bit. It could be the nail in the coffin there, but hopefully not. There's going to be loads more laws that need to be passed for the safe running of spaceports, but the government seem to want to go in this direction.
Yes.
And I think, as a way of getting out of this economic catastrophe, I think space definitely looks like a growth area. Get this, Jamie. UK space sector employs 42,000 people and generates £14.8 billion
Mother of
a
pearl.
Year. It's obviously a huge
think what that could be in the future if we tick a few of these off.
Well, yes, exactly. If we start having
Huge.
launches from the UK, it's going to be really cool. It's really cool for us, of course, because we'll be right in the thick of it.
Surely the tourism alone must be a big chunk. I mean, how many people fly to Cape Canaveral every year? Just saying.
Yeah, I mean, it's interesting because the UK space sector is really important in the world anyway. You've got this week, for example, RAL Space have finished installing this massive test chamber at the Harwell Space Cluster. And this was really cool. I saw this on Twitter. See, we were talking about Twitter and how awful it is, but actually it's great for stuff like this. And it was this enormous test chamber where they can put very large satellites in and pretend it's in space and make sure it works properly. So these things are expensive, obviously. They're the size of buildings. You should see this thing being slotted into the building. It's like the whole building is empty and you're just taking off the walls and stuff and putting this thing in. It's really cool. So, yeah, and the space park in Leicester has won £500,000 towards building the Wolfson Deep Space Centre.
Nice.
So that's all about designing new spacecraft to go into deep space. So,
cool.
This is... But not just any old spacecraft, sort of cheaper spacecraft. And as part of the £100 million space park Leicester. So Leicester's becoming a kind of real space hub as well as the Oxford Harwell Space Cluster as well.
Leicester.
Yes, if you're confused as an American, it's Leicester and not Leicester.
Made me smile on the tube. You know the way to Leicester Square? I said, oh, yes, I do, yeah. I didn't even correct her because I thought I don't want to be that guy.
I think that's very polite of you.
God knows I've got it wrong over the years in foreign countries.
Well, let's take a look at the author's name that we pronounced.
Let's just take a look at a few minutes ago.
Right, so Dr. Nigel Bannister, I don't think he can run the mile under 4 minutes. It's another Bannister, I think. He's the associate professor in the School of Physics and Astronomy, and he said, "Our knowledge of the ice giants Uranus and Neptune is based on just a few hours of data, taken as the Voyager 2 spacecraft flew past in the 1980s, carrying technology developed in the 1970s. The Wolfson Deep Space Center will develop new technologies and methods and adapt existing ones to enable smaller, lower-cost spacecraft to be used in deep space." What do you think of them onions, huh?
Well, I'll tell you what, he's gone up in my estimation. Get it, Matt? Bannister?
Yes, something about landing as well.
Yeah,
you could have
good.
that in there. It's a very good space name.
Stairway to Heaven? I know.
Oh, Skyroarer, an Edinburgh-based firm, have conducted a suborbital launch from the UK. So they're already testing their technology for vertical launch. We heard a couple of weeks ago how they'd done a static burn. And they've managed, to do... this is the second time they've launched the Skylark Nano. We say suborbital, but it didn't actually go that high. It only reached an altitude of 6 kilometres, which is pretty impressive still.
It's not bad.
What they're doing is testing the technologies for their larger rockets. They're using kerosene that they've been making from discarded plastic. So they're trying to be environmentally friendly as well.
Well, I'll tell you what, as you mentioned earlier, Matt, very exciting because we're in talks with them over email at the moment, the lovely lot down at Skyroarer, to get an interview so we can dig a bit deeper into the details.
And hopefully this will be a relationship that builds over the years until they launch Jamie into space in the year 2040.
It's all I'm living for.
I want to talk about an astronomer or a researcher, an astrophysicist called Nanda Ray.
Cool name.
And yes, she's a researcher at the Institute of Space Studies of Catalonia, the IEEC.
Nice.
And she's won a prize for her contribution to astrophysics.
Wow. For
the study of neutron stars. Now, I only saw this because a paper came out called A Very Young Radio Loud Magnetar. And she was one of the sort of lead authors on this.
Wow.
P. Esposito and N. Rea et al. She's a big shot. If you want to talk about magnetars and pulsars in Spanish, Nanda Ray might just be the go-to person right now.
So the prize worth €50,000 aims to recognise the achievements of young researchers. Fantastic job. Well done, Nanda. We doff our hats to you.
Well deserved, especially when you read this paper, because, this is awesome.
Matt, before you start, I told you earlier that I was putting a quiz together for my workmates, and we've got a space round, of course. And I was going to put, what is the heaviest object in the universe? Now, Matt, am I right in thinking that it is a neutron star over a black hole, or
you got to be careful when you use the word heavy.
I knew it wouldn't be as easy as that.
No, you got to use the word massive. A material, yes. I think because you can't get a spoonful of black hole, but you can get a spoonful of. Well, you can't really get a spoonful of neutron star. But if you could, yes, I think a spoonful of neutron star is the heaviest known material that we can conceive of.
A spoonful of neutron makes the medicine go down.
Makes the world collapse. Jamie, I'm not sure that your question even makes coherent sense, but
I reckon
you tried.
I reckon one of our listeners will know. Write in, get in touch.
Magnetar Swift J1818.01607.
Oh, yeah, keep talking.
Obviously the J for Jamie, was discovered in 2020 March when the NASA's Neil Gehrels Swift Observatory, which is a observatory that flies out at 550 kilometres in a circular orbit around Earth, a gamma ray burst detecting machine, which actually has some involvement from the University of Leicester, just to show how important the space sector is in the UK. Yes, that detected a 9 millisecond hard X-ray burst and revealed this neutron star, which turned out to be a magnetar. Now, a magnetar is a very special type of neutron star, but I'll go on to that in a second.
Wow.
So, yes, what they did, as soon as they saw this thing, they started observing it properly and revealed that it had a spin of 1.36 seconds. So there we go, something the size of Barcelona, heavier than the sun, spinning every 1.3 seconds is pretty incredible. It's quick.
Yeah.
And yes, and then they quickly asked XMM Newton, which is a huge European X-ray observatory, and NuSTAR, which is a NASA equivalent. They quickly turned their view to have a look at this object. I mean, that's incredible in itself, isn't it? That you're able to sort of, astronomers around the world have this network where it's like, stop what you're doing with the XMM Newton. I know that there's people have paid for time on it, but this is really important. So if you can skew your telescope over here, because if we miss it, we're going to miss it.
Matt, is it just coincidence that it's the size of Barcelona and Nanda is from Catalonia?
Well, it's not coincidence, actually. I was kind of paraphrasing Nanda herself, and I'm assuming she chose Barcelona because of her proximity to the beautiful and great city that is Barcelona.
It is incredible.
Such a beautiful horizon. The discovery, though, after all these observations using XMM Newton and NuSTAR and Swift, was that this particular neutron star, Magnetar, is only 240 years old. 240 years old, which is obviously the youngest neutron star Magnetar that they found. This thing is incredibly bright, and we'll get onto this in a second. It's just insane how ridiculous these things are.
Wow.
What's more incredible is not only is it giving off X-rays, but it's also giving off a radio pulse as well, which makes it unusual in the sense that not all neutron stars give off radio pulses, some do. And now we've got a magnetar that's also giving off radio pulses. So it's a little bit of a kind of, I mean, radio is at one kind of really weak end of the light spectrum, and gamma rays and X-rays are at the very, very other end. And this object is giving it all off, massive in
giving it all off. We've all had a drink.
Giving it all off. So Nanda Ray, she said, This object is showing us an earlier time in a Magnetar's life than we've ever seen before, very shortly after its formation.
Wow. I mean, it's
yes.
like you're there.
Bear in mind, Jamie, and I like this bit, even though this is only 240 years old, this Magnetar, all this is happening 16,000 years ago. So it's not really, it's actually 16,240 years old. So it takes 16,000 years for the light to get here. But the light of when this Magnetar was made would have been arriving when Elizabeth Fry, the Angel of Prisons, was born, or when Nelson was going around winning his Navy battles.
God, that
240 years ago. So that's when we'd have got the light of the formation of this new neutron star out there. So when its parent star went supernova. Not that long ago, but it's all happened 16,000 years ago, because this thing is 16,000 light years away, which actually is pretty close. It's pretty close.
I love these stats. I like it when you say to me stuff like, "Yeah, last time we were in this position in the galaxy, there were dinosaurs." I like those kind of stats, man.
Yeah. No, it's funny, isn't it? As we sort of orbit around those things. Well, I mean, that's insane, isn't it? That's how long ago the dinosaurs were to me. I think that's the way it goes for that one. I find it mind-boggling.
Weird, isn't it?
3,000 neutron stars is roughly the population that we know about. So there's way more, but those are the ones we've discovered so far.
And only 10% are Magnetars.
Yeah. Nanda says, maybe if we understand the formation story of these objects, we'll understand why there is such a huge difference between the number of Magnetars we found and the total number of neutron stars. So there's a little bit of a mystery about why that is. But I need to give you some stats. I need to give you some stats about Magnetars.
Now we're talking.
Because you might be saying, what's the difference between a Magnetar and a neutron star?
It's literally what I wake up saying every day.
Yeah, well, Magnetars have got just these ridiculous magnetic fields. This was something that people had theorized might happen. So you've got to think of, we were talking about neutron stars and how they're formed and how like you're just left with this sea of neutrons, but actually you've still got some protons that never escaped or never absorbed an electron. So you've got this ridiculously complicated structure that's all named after bits of pasta, because you've got things like neutron sheets that look like lasagna sheets and different shapes of pasta, like penny pasta and stuff like that as well. So it's very, very complicated inside. And as this material swirls around because of the spinning and everything else, you get these huge magnetic fields. But because this thing is so extreme, loads of different forces that are then acting because of the way that because of the structure that increase the magnetic field of a normal neutron star. The magnetic field on Earth is roughly 1 Gauss, right? A neutron star is normally 1 trillion Gauss, so that's obviously pretty horrendous. Whereas a Magnetar is way stronger. It's like 1 quadrillion times that on Earth. So 70 quadrillion times stronger than Earth's magnetic field.
Show off.
So it really is. So if you had a Magnetar, like a city the size of Barcelona, spinning as a Magnetar out in between the Earth and the Moon, as soon as you got about 1,000 kilometers away from this spinning city of neutrons, the magnetic field would distort every single atom in your body.
Whoa.
And essentially all the chemistry in your body would be impossible, and you would dissolve in space.
There we go.
And before this even happened, of course, the nerve signals would stop working, so you wouldn't even be able to describe your approach to this horrendous point where you would be dissolved by getting slightly too close to this ridiculous object. So get this: atoms themselves, as they approach the magnetic field, atoms that are normally sort of ball-shaped, if in a kind of classical sense, they would get elongated into cylinders. So a hydrogen atom, for example, would just become this spindle rather than a ball that's 200 times narrower than it normally is. So, we were talking about football stadiums. It would be more like a tunnel now.
Yeah.
A very, really long tunnel.
Really
long. Yeah, like the Channel Tunnel or something. It turns the football stadium into the Channel Tunnel because it's so strong.
Be much harder to play football.
And this is the sentence I was talking about that I think is quite funny. So it's crazy that the magnetic field is so strong that it should actually bend space-time.
Whoa.
But if this was the case, quantum information would be lost due to the spin-related deviation from spherical symmetry violating relativistic causality.
Matt, buy me a drink first.
So that actually might not be viable. So there's this. So this is one of those situations where the science becomes so extreme, where the situation is so extreme. General relativity and quantum theory are really out of step with each other. So come on, physicists, get your act together and sort out quantum gravity.
Sort it out, please.
Work out what the hell's going on.
Yeah. God, what are you doing?
Magnetar. So yeah, these magnetars they don't last very long because the process that sort of churns up what's known as a magnetohydrodynamic dynamo. The processes don't last very long. So magnetars probably only last about 10,000 years. So that would explain, why you only see younger ones.
I feel like I need a cigarette, and I don't even smoke.
I think you should start smoking if you feel like it, Jamie. Just do what you need to do.
Shall I go out and buy 20 Benson and Hedges?
So I do have a guest, Jamie. It's part 2 of Nicholas Booth. Now,
oh my God, yes. I'm excited.
This is a lifetime's work. His book called The Search for Life on Mars, the greatest scientific detective story of all time, which he has co-authored with Canadian whiz Elizabeth Howell as well. So this is a lifetime of his journalism condensed into a fantastic book. Really, I loved part 1, particularly his story about Feynman's dog, which was heartbreaking.
God, so good. When is this book out, Matt? Did you say?
So this book comes out on the 23rd of June in the United States, but here in England we have to wait until the 6th of August by the looks of things. So, right. But anyway.
Jelly, if you're listening, you need to buy us a book, send it across. I can't wait that long.
Well, maybe we'll get a
pre. Maybe
we'll.
If we ask nicely,
I think if we ask Nick nicely, he'll send us a preprint.
But I tell you what, you need to put that date in your diaries, peeps, because it's going to be a humdinger.
I have had a lot of opportunity to read quite a lot of it, and it's absolutely amazing. There's so many cool things in there. He really was in the thick of things. Well, as you'll hear in the interview. But anyway, Jamie, Aikute.
Let's roll it.
The Interplanetary podcast, putting the ace back into space.
So tell me, as you were going through the book, as you were going through your shoe boxes and going through all the different things, was there a story that you had either forgotten about or just kind of the next time you read it and were putting it in the book, you just thought, this is just absolute dynamite. I'd forgotten all about how great a story this is.
I interviewed the project scientist for Viking. So Viking was the big mission of the 70s. There were 2 landers, 2 orbiters, and the aim was to prove that there was life on Mars or not. And the results were very ambiguous. There were 2 experiments that sort of assumed that the microbes would be like terrestrial microbes that would adapt to the Martian environment, and a third one that was slightly more universal, you might say. And the results were you hear the phrase between a rock and a hard place. The problem with the Viking results was there was no conclusive proof that there was life, but there was no conclusive proof that there wasn't. And that's that kind of strange place where people have been in. So what's interesting to me is there's a postgrad in Paris called Melissa Guzman, who is involved with ExoMars, And she's recreating all the original data from 1976 with the original gas chromatograph mass spectrometer, which is the instrument that was used. The reason I know that without having to write it down is because I read all the stuff about Viking as a kid, and when CSI was on telly the whole time, they used to talk about the GCMS, and I thought, I know what that is, because they landed one on Mars. And so basically, what she's done is to take all the data that was then stored on magnetic discs and all this sort of stuff, and looking through it, because in the last couple of years, there's been the answer, or part of the answer, might be in front of our eyes, which is the fact that in 2008, the Phoenix lander discovered something called perchlorate. And as one of the scientists said, yes, we had to go and look up that too, because it's a salt, it's a chlorinated salt in the surface. And it looks as though that if you heat that up in a mass spectrometer, which you use to look at the chemical entrails, it catches fire. So there's this very, very bizarre possibility that the evidence might have actually been, burnt before their very eyes in 1976. So that kind of grabbed me by surprise. My co-author Elizabeth had spoken to Melissa in Paris, and she is now recreating that through citizen science. And they're using the kind of technology that we now have. There's a couple of people who are doing the analysis because they've found most of the data, and they're systematically going through to see if they can recreate the steps, because they know what they found, but they haven't been able to recreate all the steps in between. And it may well be that somewhere in those steps is a clue as to there may well have been these organic molecules that the GCMS didn't find. It may be that they were there and they sort of disappeared, for want of a better expression, in a puff of smoke.
When you start doing something complicated, particularly when you're trying to do it with a robot that's millions of miles away, then it gets really difficult, doesn't it? And say it gets really difficult is the understatement.
I mean, one of the other things about Viking, Gil Levin, who had one of the experiments, is convinced that he discovered life because his instrument effectively tested positive. But the consensus emerged actually, no, because what you're seeing is very, very strange chemistry. Now, from somebody who was asked by his school not to do A-level chemistry because it would spoil the averages of the school, it's ironic that I've been looking at this. But what is quite interesting is that this sort of, it's the fundamental question is, at what point does fancy chemistry become biochemistry? And I don't think anybody's ever had quite a good handle on that. And the next missions are hopefully going to fit in some of those sort of the key steps. So going back to the book, he said, shamelessly plugging his book, we've looked at all the various aspects of the kind of missing pieces. Because one thing that I'm old enough to remember the first generation of Mars explorers who talked about what they called a Martian horror story, which was they went straight to doing biology before looking at all the mundane, boring, uninteresting stuff to most people, which is the surface chemistry, which is the mineral mapping, which is the interior distribution of blah, 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 the magnetic fields and so on. And in the last 20 years, most recently with the InSight lander that's found Marsquakes, finally all these kind of missing pieces are coming together so finally, as we say in the book, drum roll, the Martian horror story has ended, because finally all the kind of missing pieces of the bigger jigsaw are there, so you can try and understand exactly what actually was happening on Mars 4 billion years ago, when the magnetic core probably switched off, in the sense it stopped sloshing. That's a technical term. And if you don't have a magnetic field, you've not got protection from the sun's ionizing radiation, from all this stuff, from ultraviolet radiation particularly as well. So finally all these sort of little experiments are done in different bits. It's like a patchwork quilt that they're sort of assembling into a sort of coherent whole. And these next missions that go this summer, land in next February, but they will hopefully start, now we have all the missing links. It's like, okay, let's now zero in on these interesting questions.
Yeah, I must admit, whenever I read a Mars story where it's tantalising evidence to life, and it always ends with the sentence, but it could just be a geological process. I always find that extremely frustrating.
The biologists didn't really. It's quite an interesting story because they all sort of didn't get on particularly. And that's not me saying that. That was said to me by lots of people involved in the mission. That the personal interrelationships weren't great. And one of the experimenters said, "Well, I can explain my results by you don't need biochemistry." And the person standing next to him said to a friend of mine, "Well, I can explain him in terms of you don't need biochemistry to explain him," which always made me, I always thought was a good line. It's at what point does life be? When does chemistry become biochemistry? And that's a question that, fundamentally, I don't think anybody knows, because it's a bit like a cartoon, and then the miracle happened and life emerged. And what I do think will happen with the next missions is they are actively looking towards what they call biosignatures, which are, it's not life necessarily, it's pointing you in the direction of life. So the most obvious, which has been in the news recently, is methane in the Martian atmosphere, which I'm sure you've seen. One form of methane is produced biologically, and there's this kind of methane mystery that's happening, because what's happened is Curiosity on the surface at night time will take in the sample of Martian air, get rid of most of the stuff, and look at the kind of trace constituents. These are a handful of molecules in trillions, so you're talking about a very, very small concentration. It's seen methane in parts per, I'm trying to remember the exact numbers, parts per million I think it is, and they sort of seem to fluctuate and come in, and the European-Russian Trace Gas Orbiter, not the most exciting name, but that's what it's been sent to do, should be able to see the same methane, but it doesn't. Now, the Trace Gas Orbiter instruments are most sensitive, something like 2 to 5 kilometres above the surface. Curiosity is about, 12 feet tall, and the air is coming from there. So something's happening to the methane between 12 feet and 2 kilometres, but nobody's got an explanation of what that is. So, again, it's one of these, it seems very arcane, but it could be a fairly crucial point to try and understand the chemistry of the Martian atmosphere. We know enough about the physical characteristics, the physics of temperatures and all the basic things, but the actual chemistry of what happens in this very thin, very dusty atmosphere, and that might be part of the problem. Might be the as we know, in 2018 there was this very, very violent dust storm that grew globally and knocked out the one of the rovers, whose name, because I'm old, and Opportunity.
Yeah.
Thank you. Yes, Oppie. It's any time in recent years where I've seen people cry over a robot. It's because people do get emotionally involved with these missions. But the atmosphere was very, very dusty, and it meant that Opportunity was failed because there was too much dust on its solar panels. It couldn't, charge its batteries. But the dustiness may have something to do with what happens to the methane. But these are all individual little sort of, interesting little questions. I don't think anybody knows what the answer will be, but, each time there's a mission, and the next piece will be found. And so, I'm hoping by the end of the decade, there'll be a slightly more coherent picture of how Mars has evolved and what's happened.
Yeah, I mean, I'm assuming, because I don't know anything about it, but if I was working in just normal Earth geology circles, that there must be still some really exciting discoveries and long held theories that are overturned every single year, and we're on the planet, and people can get their hands on the rocks and take them back to laboratories. So,
again, purely, he said again, plugging his own book. There's 3 schools of thought, really. One is it'll be easy to find. We'll land, and now we know there's organics there, so we know there's the biochemical backbone that could have sustained life. We know there's enough of the chemical ingredients that you need to create life. So we drill in, and we should be able to find these biosignatures which are hinting in the general direction of there might have been life. They're very, very canny and not saying we won't. No one instrument will do this, But, taken all together, different instruments looking in slightly different ways, we can piece together the next bit that gives us the illumination of what we didn't know. The other school of thought is you need to drill deeper. And the European ExoMars mission, the Rosalind Franklin rover, has got a drill that should drill down for 2 meters. Everybody knows what 2 meters is now, 6 foot. So people are saying, well, maybe that's the one that might find something because it's drilling deeper. There was a paper that came out last year that said to really look for life on Mars, you need to dig really deep, and we're talking 2 kilometers. Well, as you may have followed the mole on InSight that's supposed to dig a hole, the mole has been ratty. It's not, every time they drilled, it pops back up again. So, again, we said about sending humans to Mars, that might be a bit tough. A lot of the technological problems that you have, you're limited by what you can do. And this is why the third school of thought is just take the rocks, take the samples, get them in geological context, get the samples where, if there's water flowed through there, and that these are the rocks, the soft crumbly ones that wouldn't, if they were blasted off the surface of Mars, they wouldn't survive. We need those, bring them back, land the mission in Utah. They're talking about something like 500 grams, and each gram of this stuff will be sort of grudgingly handed out to researchers all over the world. And people are saying that's the moment that you need to be. It's silly trying to do, to put in the kitchen sink on a mission that might crash. You just bring the stuff back, and let's look at it in our laboratories.
Were you reporting at the time when Clinton stood on the White House lawn and was talking about the life in the meteorite?
I was. That was the most exciting night of my reporting career because it was just so completely bizarre. It was 6 o'clock in the evening here when it started to. There was this rumor that NASA had found something. And they brought a press conference forward because there'd been a leak. And there's lots of different theories about the leak, but my favourite one was there was a White House aide whose name, I can't remember, but I remember his name was Dick, which has got something to do with this, because he happened to be in a hotel room with an expensive hooker. And she phoned the I'm not making this up, boys and girls. The expensive escort phoned one of the tabloids, the supermarket tabloids, and said, because he'd been on the phone talking to people, and she said they found life on Neptune, which I thought was great. She got the wrong planet. That's one of the stories that came out at the time. The other is there was a leak from the Clinton White House that came from Al Gore's office. But anyway, the press conference was brought forward. And it was this kind of Pearl Harbor moment, as they called it, where they kind of emerged and presented their evidence, and it was like, wow, and it was a bit like a murder mystery. There was a red herring, there was different clues, there were all sorts of things, and ever since then, I don't think, I would say the jury is still out. We've spoken to everybody involved with, my interviews from the time with the people here at the UK. We've spoken to people in the States. And really the argument now is, yes, they found something that's quite interesting, because they found what were magnetite crystals. And in those days, the only way you could produce magnetite crystals were through biology. Well, since then, they found actually you can produce it in other ways. So the jury is still out. The argument now is about magnetite, which is a mineral that was discovered inside this meteorite. And magnetite crystals in 1996, the purity and the shape seen could only really be produced biologically. And that was one of the stronger arguments. Here we are nearly 25 years later, and they've realised that actually, maybe not. And the argument now is between experts on magnetite crystals, and there aren't that many of them on this planet, but by Jiminy, when they get together, they really give it some, because the conferences, that's all they argue about. And I think that in an odd way, the argument's moved on, and I don't think with that particular rock, because again, there's no context of where it may have come from. The evidence in itself is quite interesting, but it's all circumstantial. And I think, I think people will still, it's like Jarndyce and Dickens, the thing that went on for generations. I think people will be still arguing about this particular meteorite, but something else will be, will emerge. What was significant about that was that the meteorites were the first proof that there were organics on Mars, because there were these carbonaceous materials that are organic, the long chains of carbon, that were discovered in meteorites. So that, it came from left field. And then a few years later, there was this amazing announcement and all that sort of stuff that we talk about in the book. And it was, it was the moment when I was supposed to be meeting somebody, and I said, "I'm sorry, I'm going to be late. It looks like they've discovered life on Mars." I starred in my very own first draft of a really bad Adam Sandler movie.
What's really weird is I can kind of remember. I remember it not being as earth-shattering as I would think now. If someone said we found life on Mars, I would consider it like totally earth-shattering, and I would be sort of looking in the street, expecting everyone to be walking around slightly dazed. But I don't remember it being quite like that.
Because everybody who was involved was on holiday. The press conference was brought forward, and working then I was on the Times, we were all sort of looking at each other thinking, what does all this mean? Because it again is, with anything to do with Mars and life, there's never ever been anything particularly clear cut. Throughout the history of looking for life on Mars, there's always someone or somebody who's taken one or two bits of evidence and kind of extrapolated. The most obvious is Percival Lowell, a businessman who'd made his money and decided to set up an observatory in Arizona and spent the rest of his life looking at Mars. And he was convinced he'd seen canals. And in an odd way, that set the sort of public tone about the debate of life on Mars, because the rest of the scientific community was horrified and nobody would treat Mars seriously because of all this nutty stuff and the crackpot things that people have been saying ever since. And it really was with the space age that when the first missions went, it was, okay, let's see if we can find evidence for anything that points in the direction of life. The first mission, Mariner 4, saw a handful of craters, and it was, Mars was no longer red, it was dead. But then the next missions, they realised they'd actually missed all the interesting stuff just because of, where the spacecraft flew, which is one of those things that you thank you to Isaac Newton, you can't change that. Your spacecraft whizzes past Mars and it's got to go at a certain point. And with the cameras that they used then, they had to kind of literally zoom in with no context around. And they just happened to photograph possibly one of the most uninteresting parts of the planet. But that's exploration. In 1969 with Mariner 7, so the next missions that went, Mariner 7 flew over the boundary between the hinterland of the South Pole and measured ices with infrared, with an infrared spectrometer. And overnight, a quick analysis, it was, it looked like there was methane ice. And the scientist at the press conference the next day said, well, this is quite interesting. We don't have to emphasise why that's biologically significant. And there was a sort of gasp in the newsroom. So all throughout, there's been these observations, and then in that case, they looked at the data more, did a proper, fuller analysis and realised actually that wasn't quite the case. So I don't think ever, I don't think this mission will land and then there'll be something unequivocally wow.
Was the Clinton moment in that case? Because this is what I thought really was that Clinton moment has made everyone just slightly more cautious. Because I must admit, I hate it when people overemphasize the science and then a few months later have to roll back, and then it just makes everyone distrust it. It's like this. And there's a news story we were talking about today about this discovery of a parallel universe in Antarctica. It's like, oh, come on. It's not going to be that, and it's just going to be a loose cable somewhere.
It's almost like with life on Mars, people want it to happen and want it to be true. I can't think of anything else. If you said, I didn't exactly lose much sleep, in 20 years while they searched for the Higgs boson, but if you'd have said to me, life on Mars, we're nearly there. It's exciting, and it's something that people can understand. And what's interesting is if these next missions go and find something that's pointing towards life, I think, and we interview the people at the Jet Propulsion Laboratory, the former reporter who's now head of media relations, because it's going to come from social media. Once upon a time, people whispered, and journalists would pick it up from wherever. Whereas now, I don't think you're going to be able to hide it. I think the first hint that there's something interesting will be a hashtag, and we'll all know about it. And that's just the way that the business has changed. I mean, because I think the way that the story about life on Mars has been reported is quite interesting as well. I mean, I was second Spear Carrier Reserve Battalion for 5 minutes, but there's a new generation of reporters like Elizabeth, my co-author, who is pretty well attuned to social media, and most of the announcements about missions now, I read somewhere that JPL has something like, the 21 million people follow its social media on all platforms. I mean, that's a small country. I mean, that's amazing to me. So I think, it's an odd one because people are interested in it. It's got this kind of romantic allure, and the reality inherently, because the obvious thing is there's no Martian giraffes, there are no Martian, cats and dogs. So it's going to be fairly arcane of what is found, and it's really piecing it together to be able to to say, well, this could have led to this, and this might have led to this. That's not canals on Mars. That's not alien civilizations. But I think it's of itself, it's an attractive idea, but by its nature, we know it's going to be fairly arcane.
So, which result do you think would be the most impactful? One that says there definitely never was life on Mars, or one that says there was definitely life on Mars?
This is the place where, we prophets in the wilderness have been for the last 40 years. And I think it will be like that. I do not think that one of these missions will go and will, so what I do think is when Perseverance lands next February, the instrument that I think there's the quite interesting one is called Sherlock, which is an acronym for a long involved thing, but basically it's a series of fancy lasers and spectrometers, and it's going to be looking for specific organics. So in other words, it zaps a laser, signal comes back, and this is on the microscopic scale, and it's looking for the telltale signs of what, if you think there might be sort of organic species, you might see them. What they're also doing, which I think is quite neat, is they're taking a sample of Mars back. There was a piece of Mars that landed in Oman in 1999, and it's been at the Natural History Museum in London, and one of the investigators works there. So what they're doing is they're taking a sample that they know has come from Mars, because the chemistry's right, and you look at it and everything about it says this came from Mars. So they can test in the lab here, so they can use it as a sort of ground control truth, if you like. So they fire the laser here and they get this result. They compare to what they've seen on Mars, so they can say, yes, we know that matches, so that's pretty obviously this or that. So again, through the looking glass, it is like the chess game in Alice. You're looking at stuff that you've got to try and piece together, and it will take a lot of meticulous analysis. But I think it will hint at organic species that, again, narrow it down to what could have clumped together to lead you onto the roll to biochemistry. If they do find something in the right place that's got the right context of where it, if it was water, if it was a mineral-rich environment, if it was ancient enough, if you could tell that it had been, geologically blasted up from below, I think then you could conclude, okay, we're narrowing it down. But again, will an instrument go there and discover life on Mars? The jury's still out on that one.
Yeah.
We will sell more copies of the book if we said yes, they will. But I think, again, being realistic about it, I think, we'll get the next generation of results. And I think it's also to do with the psychology, actually, of how scientists work, because when the Viking results came, when there were no organics discovered, that was game over, and I think no analysis was ever really done at the time. It's taken 40 years for all these other different clues. So it's the shock of the new. So I think that when something's discovered, perhaps in a sample that's then, they do fire the laser, that's priority to bring back, it's looked at. I think we'll get the next steps that will give us the hint of what we might find. And one of the interesting things is we'll have to wait to 2022 for the ExoMars mission, because one of the instruments that it has, which is the kind of European equivalent of the Sherlock, in very, very simple terms, it's got the chance to be able to look at a property called chirality, which is left-handedness or right-handedness. And that's really interesting, because if they find proteins and they find kind of sequences of different stuff that is obviously very different from what you find on Earth, and it has these chiral properties, and the way you do that is extremely fancy chemistry, and, we've spoken to people about this, and it's possible that, if they find something like that, that would be, then that some sort of biochemistry happened on Mars. But even then, it's still not a slam dunk.
No, well, someone can turn around and say, "Oh no, but I've managed to find another process that does it." I mean, it just seems like you can always keep. I mean, if there was a chance of definitively saying there's life on Mars, what happens next?
It takes life from being a miracle to an irreducible statistic of 2. And that, to me, is what all this is about. In other words, if you go to Mars and you find life, then you can say pretty confidently that there's probably a lot more chances of life in the universe. And it's that, the famous Drake equation that's lots and lots of numbers, and you can then start plugging in, because if you can say, okay, here are 2 planets that have undergone all this geological, evolution, there's been asteroid impacts, they've probably over geological time shared spit, in the sense that stuff landed on Earth, stuff landed on Mars that come to. There's an argument to say that life is easier to have formed on Earth, but it could have been sustained on Mars and what have you. It doesn't matter what's happened, it shows you that actually here are conditions that have allowed life to take hold. And I think that will be, I'd like to think it was a important and significant moment in world history, but nobody knows. But what it does prove is that then life, you find life in the most obvious and likely place, then you can say, okay, it's probably pretty likely there's life all around the universe.
If there is current life on Mars, as in there is living organisms that are currently living on Mars, do you think that has an even greater impact? And I'm thinking of not just the kind of, like you said, this psychological element of how common is life in the universe, but also in terms of its impact on space exploration, full stop.
I mean, that suddenly then takes it into a different arena that none of us know. As we've been writing the book, we could only realistically predict what would happen to this November, because we don't know who the next American president's going to be. So here we're talking about something that could possibly have happened. So this isn't Carl Sagan, this is Jim Bowen on, Bullseye. Here's a planet that you could have landed on, sort of thing. We don't know how people will react and what the life will be like if it's there. I think it's more likely there'll be signs of extinct life somewhere in an ancient surface somewhere that somebody will dig. But if they find, if something's found with current life, it may well be that the radioactivity in the rocks and the sheltering from all the stuff on the surface, that might be able to make these things might be viable, so you might be able to bring them back to life. And that is, more than anything, a really fundamental question of ethics. Is should we do that? No, I'm not equipped to answer that. One thing that I do think that's going to be really interesting is, you think what's happened here in the last couple of months, a virus that spread. I think, if something is discovered on Mars, and it's possibly biological, and it could be extant or whatever, there will be enough people who'll be saying, whoa, leave it there. I mean, that's the stuff of science fiction and the philosophical things, and I don't know. And I do think you won't know the answer to the question for probably the most part of this century, but if it's... Let me put it this way: if it's there, it will be found. If it was, around enough to be able to do that, I think people will have discovered it.
Yeah, I mean the biomass that's buried deep in the earth is apparently more and more surprising every year. That's something I was reading about this morning, actually, in Nature, about just how the deep underground is much more full of life than anyone thought. So it could be the same with Mars, couldn't it?
What's also interesting in the last 40 years, biologists have found life in really, really odd places. I mean, inside nuclear reactors, in the kind of the most high ionizing radiation environment you could imagine. They found it in the stromatolites, which are these odd sort of chemical, almost like biosignatures, that at least go back to 3.5 billion, and people have said we think we found them in 3.8 billion in Greenland, which is just the basic precursors and the first signs of life, for want of a better expression. So, yeah, I mean, it's a great question because there's so many unknowns. And, if you say, okay, well, we take all this, it could be that Mars is full of life, or could have been, or it's been completely dead. And either way, it tells you something important. But I do think that life is hardier than a lot of people thought 40 years ago. And I do think if it ever got started on Mars, then it will, the signs will still be around. And I think, that's I think that you can answer that question to say, wow, okay, what do we do next? And that's up to everybody to pitch in with their penny's worth.
I mean, there's even the sort of extra philosophical element to it, as if you discovered life on Mars and you were able to show either of these two possibilities. One, that there's a panspermia going on, that either Mars seeded Earth or Earth seeded Mars, or that the life on Mars is absolutely completely separate to the life on Earth, as in that there was a genesis moment
that will be if you can find the chirality of molecules that are precursors to biology that are in a completely different sequence, the genetic sequence is different, then that roll of the cosmic dice has created something. You've got the curious thing about the timescales, because we know, okay, so maybe over 1 billion years, and some of these chemical processes take place in trillionths of a second, but trillionths of a second over 1 billion years gets you to an interesting point that you could have produced something. But as a well-known television astronomer used to say, we just don't know.
Yeah, but that's presumably what all these spaceships and rovers are supposed to let us know.
Well, eventually, yeah. I mean, we can argue the toss and say, well, how many rovers do you need to be able to do this? And then if you have human beings traipsing around on the surface, because they can't. We know that by international treaties you can't land in the special regions, which is where there's evidence for water today. Because that's the other big question is the question of water on Mars. That is that I think the answer to unlocking the question about the biology is to look at what the water did on Mars and where it went and how long it was there. Because there's now this sort of fairly interesting debate of, was Mars ever warmer for long enough to have had a vast ocean across the northern hemisphere? If you look at Mars, the southern hemisphere is all cratered and pockmarked. The northern hemisphere is much flatter, and there are some very, very, trackless expanses that various people have said, well, there could have been, oceans on Mars. One of the people we spoke to, the best description I've heard of that is, some days I think it's really likely, other days I think it's very silly. I thought it was quite a good quote, because there's two schools of thoughts. That the geologists are looking for from the geological evidence, you'd say there must have been water, or at least maybe sort of some covering of an ocean or something, the atmospheric modelers can't get Mars to be wet and windy for long enough in the past. And again, it's one of these things that sounds like, it's scientists at conferences arguing to, reductio ad absurdums, but actually no, it's a sort of fairly fundamental point. If there was water around for long enough on the surface, for many, many millions, it didn't have to be billions, life could have formed, because the oceans on Earth have always been quite a good crucible for all sorts of biological activity, including the thing of hydrothermal vents, which I think is probably the clue that we need to find to see if there would have been life on Mars in the ancient past. In other words, you've got water, it was heated from the volcanic activity, but it's shielded from all the stuff that's happening. You need to make sure the waters of the chemistry of the water is just so. It's the Goldilocks question. It's not too hot, it's not too cold, it's not too acidic, it's not too alkaline. And that will take a systematic, that's not front page news. That's 20 years of, postdocs doing fairly arcane and obscure research. But at the end of it, they'll come out and say, actually, yeah, we think this happened. And that gives you the clue.
You've hinted that you had a bit of a hiatus in between, like the early Mars days and this latest book. Was there anything in particular that kind of dragged you into the fray, as it were?
That's a good question, actually, because what is quite interesting is I, started on an astronomy magazine, then did newspapers, and then at the end of '99, went into the glamorous world of television, and here I am now, 20 years later, a broken man. But I was still interested in and stuff, so I'd see stuff on news or social media and think, oh, that's quite interesting. And I think really it was probably Spirit and Opportunity that had found, somebody made the comment once about, we've discovered water on Mars again, because it's been known from, certainly in the years of space exploration, but it was really the kind of what Spirit and Opportunity found, because they were landed on completely different hemispheres of the planet. The chemistry of the surface was different, as you might expect, but there was lots of evidence in different ways that there was water there, and particularly hematite, which is an interesting. You can only really create hematite, which is, you've got Mars, which is, it's red because it's rusty dusts, and you put rusty dusts into water and sort of heat them over geological time, and eventually one of the outcomes is you get hematite. And it's quite an interesting thing to say, actually, that's quite interesting, because the conditions may have, to create hematite at that level that you've seen, maybe the climate was warmer. So I think there's enough clues have been amassed over the last 20 years, and certainly when, after Curiosity landed, within a few weeks, it discovered what was obviously a stream bed, and there was there's a Yellowknife Bay, as they've called it, that was like nowhere else on Mars had ever been seen before. And the way to explain it again is there must have been vast amounts of water around for sufficient time to have created that. So it's, again, this narrowing down. What does make me laugh is, because I've been doing history and crime and all this exciting stuff, and occasionally on Twitter I'll post something, and a couple of people said, you know a lot about this. It's like my secret history is that I was a Mars nut in my teenage years. But I do think now is a great time, because there's so much going on and there are so many different areas that you can look at. It's, I think we're going to hear a lot more from Mars, and there's going to be some fairly exciting stuff. But I can't tell you what that will be.
I think, just because of the age of the internet and the age of social media, like you were saying about this JPL and all the people that follow that, and the fact that there's new and exciting missions going, perhaps we're going to see a whole new generation of Mars nuts.
I mean, the dedication in our book is this: at the end of the book, we thank we thank everybody we've ever met, and we say it's our hope that somebody who reads this book will actually go to Mars, and if you do, don't forget to write. Because, we've heard that trite thing, the first person to land on Mars has been born now and all this. And I do think that history does provide the clue that, let's say, from the first era of exploration, Vasco da Gama, and all, it was 60 years, and then it was another 150 years. So maybe into the 22nd century, that's when we will become, there'll be much more routine travelling around the solar system. I don't think it's not quite as easy as people have maintained. It's not going to be, there will be deaths and there will be, horrible things that will go horribly wrong. But it will be worth it, because I do think, if we can find something interesting on Mars that hints at life, as I say, our, chemical brothers and sisters and whatever you want to call them in the universe might be there. Until
speaking to you, I hadn't really kind of got the significance of this sample return. I suppose that's the big one that we really should be looking forward to, isn't it? Rather than thinking too far in the future.
This was why we stopped the book there, because what's interesting is that Curiosity was supposed to last. I can't remember. Was it 2 years? And I can't remember if it was 2 Martian years or 2 Earth years, and here it is 8 years later. So, excuse me, as Perseverance goes, it may last for another decade. So they're thinking now, because the specifics of returning the sample have not been defined yet. Since the book's gone to press and we were able to add, a sentence. One of the fundamental problems is, in the same way the entry phase of landing on Mars, the 7 minutes of terror, going back up through the Martian atmosphere is exactly as unpredictable, because you don't know. The Martian atmosphere, although it's very thin, although it's the same pressure at 100,000 feet here, so, there's not much atmosphere there. It has very, very odd properties, one of which is to do with it expands and contracts, and that's been measured at the surface by pressure sensors. And you're trying to come in or take off like Buzz Lightyear, and it's really tough to be able to predict to do that, because then again, in the same way, because Mars is so far away, the average is 12, 15 light minutes. So in other words, by the time it's landed, you've got to wait 15 minutes for the signal to tell you that it's arrived. Well, it's the same going back up through the Martian atmosphere. That whole process of getting this sample, putting it inside this rocket, firing it, getting it into orbit with a kind of giant, here's another technical term, a giant mitt that catches it, that will all have to be done automatically, and any changes to the orbit, so this thing that's shooting up from the surface might appear at a completely different place that you're expecting, because it's encountered high altitude winds that you don't know about. So, as I say, there's a lot of breezy hype, but actually the reality, it may well be that they don't get it right the first time.
Yeah, not just might be, presumably that's a pretty big risk, isn't it? Because it's not like you can really practice that kind of stuff anywhere else.
No, and also because here's the interesting thing: you land on Mars, and for the first time, you've got to take the rocket that is going to fire you back up to Mars orbit, and that means you've got to control this in a thermal environment that is, rockets by their very nature tend to, when they go, there's a controlled explosion. You want your propellants to undergo a controlled explosion, not one because the temperature rises because you've missed out something, and there's an explosion, and how do you keep this stuff for this length of time? And what NASA have said recently, they've said it'll be the ascent vehicle will be 2 stages, and it's probably going to be, a solid propellant. Well, the problem with keeping solid propellant, you can't have it much below, the freezing point of water for any length of time. So you'll need to have something to keep its thermal activity controlled, and this, suddenly the designs I've seen for these vehicles, they're like Topsy. They keep growing. There's no doubt in my mind that they'll get it right. One of the reasons why ExoMars has been delayed is to make sure that the parachute mechanism works. And, they're talking about a 2026 launch of the lander that goes down, and the same one with the European, the thing that will bring the sample back. And then what they've got to make sure, because that's, the ascent through the Martian atmosphere is going to take, quite a long time. The next stage is, how do you make sure that you, what they call, break the chain? And what that is, to make sure that the bit of Mars that you bring back is completely isolated from the Earth's biosphere. Because you don't, if there's a very, 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 very small chance that there might be something unpleasant and nasty, and you don't want that being entered into the Earth's atmosphere. So there's these sorts. Again, there's nothing that makes you think this can't. They don't have to invent dilithium crystals or whatever it was in Star Trek, but it's lots of sort of daisy chains that you've got to get each bit right. And I think they'll do it, but if I was a betting man, it might be they might not do it all in one go.
I mean, it's super exciting at the same time. I think when you kind of start to get a handle about how tricky everything is, it's like, even down to, like you said, just the storage of the fuel to get you back off, and all those different choices that you have to make, and all the different design things.
Let's not. If I wouldn't be a holiday rep for Mars, it's not a particularly pleasant place to land, because there's the radiation, the dust, even the chemistry of the dust. I mean, one of the things from Viking was there were these what they call superoxidizing elements in the soil. So an astronaut lands there, puts the flag down, says, right, let's crack open the sandwiches, and goes back into the vehicle they've landed in, and all this stuff is on the spacesuit. I mean, that hadn't happened on the moon. I talked to the Apollo astronauts, some of them, and they said, the moon smelt like cordite because there was all this stuff, and it smelt like gunpowder. On Mars, if you take your helmet off and you're there in your spacesuit, and there's these peroxides that you then inhale, they will bleach your lungs really, really badly. So, landing on Mars in sometime this century with human beings, there's another iteration of all this sort of stuff. But genius is where you find it. Somebody, hopefully listening to this podcast, will think, I know how to do that, and will be involved with it. And it is, as you say, really, really exciting. And to answer this without sounding like a politician, it's been great to be back on Mars, because my interest has been ignited again, because we're at this next stage of bringing the samples back, and we've talked to people, and they say that's really the moment. Orchestra swell, end titles. That's when it takes it into overdrive. And I do think over the next decade we're going to get lots of interesting results back.
Have you got a favourite piece of space-related music that we can stick on our space playlist? And David Bowie is completely taken.
There's a fantastic Japanese techno artist. This is 1950s radio. I'm glad you asked me that question. I understand there is a young man who is a techno artist. It's called the Sushi Club, and he's a Japanese techno electronic type person who lives in Germany. And there's a track called Dino no Sekai, which I'll send you, and samples shuttle dialogue. And I think it's from Hubble. I think it's from when the two astronauts, when Kathy Sullivan and Bruce McCandless went into the airlock, which I was at Goddard to watch, is where, and they're testing their comms and different stuff. It's a brilliant piece of music, and I'll send you, because in a very, very odd way, that has the space stuff. I'll end by telling you a very, very odd story, which again is, from the annals of space reporting. When we went out to see the launch of STS-31, the launch was it was supposed to go on, I think it was the 10th of April or something like that in 1990, and 8 minutes before liftoff, one of the APUs, the big power units at the back, failed. And what was quite interesting is at the press stand, all the local photographers, so these are the guys who know all this, they started packing their equipment away, because they knew that it would take 10 days to recycle everything, to take all the units out and be. So 10 days later, or maybe a fortnight later, I'm there. And the Kennedy Space Center is, the best way I can describe it is a series of freeways with lots of fences around it. and lots of armed guards and lots of Marines. So we to get to the press stand to see the launch is we had to be up at like 4:30 and had to leave the motel at 5 o'clock. And you get there, you show your credentials and all that stuff, and then they let you in. And this is a very strange moment. Every time I hear Another Day in Paradise by Phil Collins, which is not the most obvious space music, but that was on every FM station in those days. You know, when it was all analog, it wasn't digital. So a station would fade in and then another, and that opening to that always reminds me. And still, what I think is probably I've told you about one eerie thing, which was Tara, Feynman's dog. The other thing, and I only thought of this recently, was when went out to the Cape to see the Hubble launch. So we let in, we're driving along, and there's all these freeways, and in the middle of nowhere, there's a traffic light that suddenly turns to red. So we pull in, and then in the distance, this van appears, and at the back there was like two motorcycle outriders and a kind of a van, a lorry which Marines sit in war movies with guns, and this entourage shot past. And very, very slowly, it dawned on us what we'd just seen. That's the astronaut transfer van. You know, you see them walk out, they get in the van and they wave. And we actually saw that because we just happened to be at the right spot at the right time. And whenever I see, shuttle, that moment of suddenly realising there are 5 people inside that van who in an hour and a half are hoping that the explosion that they're sitting above will be a controlled explosion. And at the time, it gave me goosebumps. And whenever I think about that, I've got them now. But not from listening to Phil Collins, that just happens to be there. So my 2 space pieces of music would be Dino's, the Japanese one, which I can't pronounce, and Another Day in Paradise. And thank you for letting me wit it on.
The Interplanetary podcast is alive!
There we go. So it only leaves
as always
one last thing to do, Jamie.
Go on,
and
then.
That is to thank the great Patreons.
We've said it before, we will continue to say it. You make this podcast happen. We couldn't do it without you. Thank you for all your support. And thank you for people on our Instagram page, liking our nonsense and commenting, and people going onto iTunes, giving us 5 stars and the reviews. Honestly, Matt, I read the reviews again the other day and it warms the cockles of my heart.
Absolutely.
To see that people enjoy this.
And if you've got great stories, we love it when people write in and say that they've packed in their job and started an astronomy degree and things like that. Those things are literally absolutely amazing. So please tell us your stories like that.
Please tell us your
stories.
I'm
going to read out the list, Jamie, of the legends that
let's hear it.
Dr. Bob Hodges,
Ooh.
John the Adventurer Benak,
Karel
Sim, Julio, Space Transportation God Sven Nauhaus, who is extremely good at the old book recommendations. Ronald Hatcher, Marissa Davis, Patrick Haywood, Mark Sean, Mark Modular Synth Sean, Stas Shusha, Christopher Andreasen, Rob the Architect Annabelle,
Rob,
and last but not least, the 3 gods, Auden Vala, Tupper Hyde, and of course, Anthony Peggs. You sounded like Tarzan then. That was amazing.
I'm hoping someone from Disney's listening.
Right, that's it, Jamie. Shall we let the Spodcats go?
Let's let them go. Have a wonderful weekend, everybody. And remember, you're special, you're beautiful, and so is your solar system. So continue to look up.
Continue.
Yes.
Goodbye, Spodcats!
See you soon. Bye.
Bye.